Hello, everyone. It is a great pleasure to be here at Coalesce to present our case. I'm Felipe Leite. I'm a data product manager at Miro, and I'm going to be speaking with
Steven. I'm Steven Pastan, an analytics engineer at Miro also.
And today we'll share a bit on what was our story, what was our saga of scaling analytics at Miro. This is something that the purpose of the talk is to hopefully help other teams scale as well. And the reason why we chose to present this is because we learned so much from previous presentations in Coalesce. They were sharing their story, how they also scaled, the challenges they faced, and we learned a lot from it, and we wanted to contribute. So just to give you an idea of where we are now, this is a bit of a snapshot of our DBT repository. So over the past month, we had 250 plus pull requests, 60 people collaborating, and we'll talk about how we got here. So the structure of the talk, I'll start by talking a bit about what is Miro and where we were and where we got to, and then we'll cover a bit more details how we got there. So first of all, what is Miro? I have a bit of a quest from our marketing and GTM teams, and they wanted to see kind of how is the awareness of Miro in this segment of analytics, Europe. So I'd like to get a show of hands of who here knows about Miro. Awesome, a pretty good awareness. And now for a last show of hands, I promise. Who here currently uses Miro, personally or professionally? Amazing. We also got some mentions in the talk earlier. And if you checked in Coalesce sessions, there's often some Miro diagrams hidden there. All right, but this is Miro. Miro is where teams get work done. We are an online collaboration platform. And to give you as an example, this very talk was created using Miro. This is a screenshot from sometime this week, me and Steven working together on this presentation. But that's not all. In Miro, we have a lot of different use cases, user types. So here on top, you can see some workshop. There are planning sessions, diagrams. Here on the bottom right, there's one that I saw this week that was a chemistry class, and they were drawing up atomic structures. So we have users from preschools that are drawing things with kids. We have universities that are teaching students, large enterprises, small businesses, and everything in between. And with all these different use cases, we are very curious to understand kind of what are the things that are working well, what are the things that are not working well, what are the new types of use cases that are coming up. I think I've also seen like people doing video game lore, and they draw out on the board, movies and everything. So a lot of interesting use cases. And that's where we're trying to use data to see kind of what is working well, what kinds of features are being leveraged for what kind of users, how's the retention, are people coming back, which features drive more engagement, collaboration, and so on. And this is what Miro looked like in 2020. We really had this inflection point at some time in 2020. I think you may have an idea of what that might have been. So this was February 2020. This was COVID. When this hit with lockdowns and everything, we saw people that were already working with remote work, hybrid work. They were increasing that. And some people that didn't do that started doing that. So even universities, schools, again, so many different cases started adopting the tool. And this is a representation of what the analytics team was looking like at Miro. So we started off here in the left with 8 people. This was the analytics team. And with the increase with COVID, we were looking into increasing this by a lot. So we saw that this went on, and we would go into having 80 plus people, 10xing the team over the next period. There was a lot of unpredictability, so we didn't know exactly how much we would have to grow. We just knew that we would need to keep up with the business somehow. And this is a bit of illustration of how it started in the left, as people were co-located, people working together, smaller teams, and this is starting to break into different hubs, different time zones, async work, a lot of new people that didn't share the same context of the people before, and this was happening across the entire company. And while the active user graph looked something like this, In terms of data, things got really more complicated because when you're talking about data, every day with more users, we get more and more events. We get more and more analysts, more and more people querying things. So this really multiplies into a really crazy scale. So the question that we had, and what we'll try to convey a bit in this talk, was how do we scale analytics? How do we scale analytics to keep up with the business and still be able to address all these questions and try to find the things that are working and things that are not working? So I'll pass it over now to Steven to talk a bit about the phases that we went through.
Awesome, thanks, Felipe. So in our kind of analytics engineering journey at Miro, we have kind of three vague phases. The legacy, which is the pre-analytics engineering, and then the early modern, which is our first attempt at bringing the modern data stack to Miro, and then the present day, which is kind of when we hit those straining points as data volumes and data load increased, and some things we've done to try to mitigate those problems. So yeah, legacy stack, just a few things to say. No AE, as I mentioned, commit directly to main every single time. Infra was flaky, dev experience was difficult for analysts and data modelers, and code duplication was rampant. And we'll get into more detail these points later on in the talk. The early modern stack, enter AE, we're trying to support the company's growth with this new team, and yeah, as I mentioned, first shot at the modern data stack. So as continued growth happened in our company, this really pushed the limits of the data stack. We ran into some interesting problems we'll talk with you about later on. We made some choices, there were some successes, some not successes, and some open questions we'd love to discuss with you. So below we have kind of 4 stories that isolate different aspects of analytics engineering at Miro and what our experience was like. And each of these we'll take through the 3 eras and kind of show you what it was like at these different phases. So the first one is about analytics engineering's role at Miro. So in the legacy era, we have kind of a Wild West-y picture here. I don't know if it's easy to see. But yeah, analytics platform was ownerless. Analysts collaborated sometimes, but not systematically. Transformation of data was all over the place, mainly in the BI layer, but a couple of other places as well. It was really every analyst for themselves. In the early modern era, we saw that the analytics platform was ownerless and felt this was a big opportunity to help analytics support the business. So we took ownership of that area. And data engineering and analysts, we kind of left to areas where their expertise and interests were better suited. So for data engineering, we had them worrying about things like first-party data, ingress, egress, orchestration, and so on. And analysts, we really wanted to focus on insight, getting to know the stakeholders, and knowing their domains, being the experts in their domains as much as possible. So the early modern era. So we started to focus on the analytics platform, setting up all these new tools and standards and workflows and onboarding folks to them. And yeah, little shout out to dbt here. We really doubled down on dbt as a source for all of our business definitions. So if we had a definition, we wanted it to be in dbt. So analytics engineering's role here was like first a big onboarding push, as mentioned. Like, at the time we had probably 30 or 40 analysts. We had to set them up with the new tools, get them used to Git, things like that. And one big thing we want to mention is how much easier it was with dbt's resources. The docs site was incredible. The Slack community was great. We're sending links around all the time. Analysts could also self-educate, which is a learning method many of them preferred by exploring these resources. So it was super awesome for us. As adoption of the analytics platform grew, so did our need to support the analysts using it. So I mentioned in the early modern era, it kind of started with 2 AEs, 30 or so analysts. It grew to about 4 AEs and 45 analysts or so. And you can imagine they're using new tools. They're in Slack asking us questions about how to use them. And we were doing our best to support them there. But it was as a straining point for us, there's a lot of ad hoc work, random Slack questions popping up all the time, interrupting more longitudinal projects we wanted to focus on. And it was also hard for us to estimate our workload. We didn't know going into a sprint or a week how much we would be asked to do in terms of this analyst support. So in the present day, we had this insight from working closely with analysts, which is all of these big questions that landed in Slack arose mid-project. So imagine an analyst comes to you and says, oh, I've been building this thing for a couple of weeks and I'm getting a timeout. My query's not running. What's going on? A lot of the times we'd say, oh yeah, we'll take a look, and it looked something like this, big, tangled mess, and it would require a really big intervention from our part. So the idea we had was to consult analysts from the start of their projects. And this led to what we call the peer system, where each AE is assigned a group of analysts that they work closely with, and we try to get context on what the analysts are doing so we can provide them the best advice. And in this regard, analytics engineers are kind of an implementation consultant for analysts. So this is a little screenshot of one of our internal Miro boards where we have analytics engineers matched up to analytics leads. They're focusing on separate areas throughout the business. So this is kind of how we set things up. So what would we give advice on? So the kind of common questions that come up when anybody's data modeling. Do we build this in the BI tool or the transformation layer? Should it be centrally built? Should it be in a mart? Also, this thing you're planning on building, it's already been built. Talk to this analyst. They have a lot of good context here. So another shout out to DBT. DBT really made it possible for us to enable analysts to transform their own data. And this was a big thing that helped us scale. Analysts transforming their own data was a big thing we could leverage as the business grew. So yeah, just a quick point there. So big advantages of this peer system. Early interventions are often smaller. The ad hoc work is reduced. It's easier to estimate workload. And also, we can help explode, destroy silos by kind of having more context on analysts' projects. So wrapping up, at Miro in the current day, analytics engineering balances this kind of platform and peer aspects. So on the one side, we're still owning the platform, developing it, working closely with analysts to make it the best we can, and also a peer aspect where we try to provide good advice to analysts on their data modeling projects. So we still have some open questions for the future of what analytics engineering at Miro will look like, a year from now, 2 years from now. So should every analytics engineer do everything? Should every analytics engineer both have platform and peer responsibilities? Also, what would it look like for analytics engineers to be more deeply embedded in domains? How far should they be embedded? What does that look like? Awesome. So now I'll hand it over to Felipe to talk about enabling DBT at scale.
All right. So we go back now to where we were in terms of infrastructure before we had this push and the AA role was created. And our first mission was to get things in place so that we could push for adoption of DBT and data modeling best practices to analysts. And this is where we were in early 2020. I'll cover briefly what our stack looked like. So we had a bunch of different data sources, a couple of different data ingestion tools, loading things to what was kind of let's call our data lake here, a combination of S3 and Postgres. We had an early stage DBT project that was using DBT Spark and DBT Presto, and we were testing kind of how each of these worked. At the time, they had some things that either of them didn't have in terms of features, so it worked as a bit of a complement. We had Looker, and this was kind of the key part of our stack back then. I'm going to go deeper into this, but we had a lot of modeling happening here. We had Amazon Data Pipeline. Hopefully you don't know what that is. Bitbucket Bamboo was self-hosted, and we also kind of had to do something about that. So zooming into the transformation part, we are facing a lot of different challenges with this stack. So one is that this was self-managed, and we did not, with the scale and the pace that we were growing, it was very hard to keep up. So we were speed running through bottlenecks. Every week something new blew up, and we didn't know what to do about it, or how long it would take, or what was even going on. We had a lot of queue problems, or a lot of people trying to open their Looker dashboards and client infrastructure. And what happens when we have queue and the dashboard doesn't load? People open more tabs, they refresh, they make the problem even worse. So that was hard to manage. analysts didn't have really access to a lot of this, the part of the stack around the modeling. It was complicated with the LOS account and so on. They had to deal with multiple SQL syntaxes. And whenever we had multiple people developing at the same time, things would start breaking. The cluster would go down. It was very complicated. And the bulk of our transformations were happening in Looker PDTs that give a lot of flexibility, and you can go really fast on these. But once you get to a certain point in scale, this stops working super well. There are some improvements on this. Actually, there's a new blog post from Spectacles on kind of like revisiting the PDT versus DBT comparison. And we had, as I said, a start of the DBT project. And we saw how powerful it was, and we wanted to kind of see how can we enable this to go into large scale. So this was the state of the data. We had frequent downtimes. We had changes happening directly to prod. We had layers of bottlenecks. Things would break in Looker, would break in the EMRs, would break in Spark, would break everywhere. And we had increasing volume, increasing demand, so we just knew that everything would just keep getting worse. And we were already stuck in daily firefighting mode. We did not have time to really invest in other things as we were trying to just keep up with whatever was breaking at the time. So that's when we set off our goals for our migration to change how this was working. This was about to start when the analytics engineering team was there, and we started pitching for this. So we wanted to get to a point where we had reliable execution, the management overhead was lower, and hopefully we just needed to do things more proactively than reactively. We wanted a nice speed of iteration to test things, new setups, spin up new warehouses, change how things are working with ease. One SQL syntax that would be helpful, and a better user experience overall. Working across the previous stack, you need to go through a lot of different hoops. It was not that great. So this is more or less the journey that we went to get there. This could be a talk of its own on how to go through all these steps. But first is just making the business case, try to say like, oh, this is what we want to do. And in our case, it wasn't that hard because of how bad the situation was. There was not a lot of convincing to do. Procurement POCs and testing out different solutions, that took a while. Then once we picked a solution, set everything up, load the raw data, set up DBT for it, and then start building the stuff in the new stack. This was a huge joint effort, took buy-in from a lot of people from different teams, a lot of collaboration, and many, many Miro boards involved in this process. So this is where we ended up in terms of the core part of the stack. We went on with Snowflake, and we saw how it could be really powerful in reducing the amount of low-level issues. Oh, you don't have enough memory to run this. Oh, there's partitions are whack, or there's data skew, or I don't know. This was a much better situation. We had better profiling and logging to diagnose problematic cases, less things to fiddle with to fine-tune how clusters operate and everything. Better overall performance. That wasn't really the goal. We wanted to stabilize things, but that was nice. We finally got a nice support for incremental models. We really wanted to leverage this because of the volume of data that we were facing, and a lot more handy features. And this allowed us to start moving everything from PDTs over to DBT by having a nice experience for people to work with it. That we'll cover in a bit. One really nice aspect as well of Snowflake that we really leveraged to prevent things breaking in prod and having a way that people can test things without being afraid that it would break other people's work was using Snowflake's zero-copy cloning feature to easily create development databases. So this works kind of like the FUR in DBT, but at the database level. So instead of actually copying the data, it's just pointing to the production database through metadata. So it is copying metadata. And this worked out quite well. And people had their development databases, they could try things before pushing to or opening a PR. And that brings us to the present, how our stack is looking like overall. As I covered these changes, we got the engineering team collaborated a lot to move us to Airflow, the DevOps team to move us to GitHub, and we were in a much nicer setup. But there are still challenges, of course. This is not, getting to this point of the stack is not a panacea. There's still things that will come up that you need to face and handle, and I'll cover a couple of these. Number one is this expensive incremental refreshes. So incremental models are great but we have some incremental models in Miro that are incredibly expensive if you want to do a full refresh. Something like, I don't know, thousands of, euros. And it's equivalent, if you accidentally run this, it's equivalent to you throwing your MacBook out the window. That's 1,000 gone. And we didn't want this to happen. So we started setting up specific warehouses to run incremental models, setting up specific timeouts to avoid cases where people would full refresh something and just keep running. And we started to also set up deploys to full refreshes only through GitHub Actions, where we could have a review process that someone would take a look, authorize, okay, this is good to go. And we still face a couple of, it's still challenging. So there are still a couple of things that we want to try to have a better standardized incremental configuration to allow for the case, for example, there is, whenever that happens, a sad day of incremental models that run with bad data, and now you have to go back and try to clear that up. So we're trying to see what ways we can deal with this. If you have suggestions, comments on this, reach out to us in Slack or here. Another big thing is data warehouse optimizations overall. There was a talk this Monday, I think, from Select on ways that you can optimize Snowflake spend. And there are a couple of considerations that you can have in terms of what kind of materialization strategies you go for, how you're going to cluster things, what kind of parameters your warehouses will have. This is very, you need to benchmark yourself and so on, but in this talk there's a lot of nice tips and tricks and tools. And another part that started off quite nicely but started getting a bit complicated was the cloning, as I mentioned. When we started off, we had this setup where cloning would take about a minute, and it was great. But then as the volume of data grew, so does metadata. So even though it's just copy metadata, you can end up with a lot of metadata. So cloning started taking over 15 minutes. And we're trying out to figure out what can we do about this. This is kind of getting quite slow. And one thing we realized, I'm not sure how often people do this, but instead of just running a clone database, and I know this is specific to Snowflake, but instead of just running a clone database operation, if you clone tables and views, and you just fire a bunch of clone operations for these, somehow this works much better in parallel in Snowflake, so we managed to bring down back time to about a minute. There's more variability with this, but it really improved, and we got this kind of really fast cloning. A couple of things we want to try next as well is to have like scheduled cloning so that DevDBs are often refreshed automatically. There are options to have pass-through views where you just have views in dev that points to the prod. And one thing that, shout out to Tom, one of our data engineers / analytics engineer, that he's coming up with a smart defer functionality leveraging DBT so that you can just defer to whatever, like if you just want to build one thing in dev, that defers to prod, and if you're just building a longer sequence of models, then it doesn't defer. And also shout out to Felipe that helped us out in terms of kind of understanding how these differences between clone processes work. So wrapping up on enabling dbt at scale, reliable infrastructure is essential. So we saw how powerful it was to be in the state where you didn't have to worry about low-level issues. It increased time available for new initiatives. It was easier to push for adoption of dbt, and it got us from the state of reactive firefighting into having time for prioritized optimizations. And now I'll pass it over to Steven again to cover how we leverage this.
Awesome, thanks, Felipe. So this story we're calling reliability and speed. And here we'll be talking a lot about CI. So for those who don't know, CI stands for continuous integration. And it's the practice, the kind of software engineering practice of continuously integrating changes into your code base. And I have a little cartridge here because it's kind of the opposite of that. Like once the software is in the cartridge, it doesn't get updated again, you need a new cartridge. So kind of very non-continuous. But here we'll be talking about CI as actually the automatic checks on proposed changes that could facilitate this CI practice. So yeah, this is kind of the anatomy of a contribution. We have the analyst on one side and main on the other side, and they want to get their changes into main. So they have to go through CI, just mentioned these automated code checks, and a review process as well. So something to emphasize about the difference between CI and review is manual. You need a brain, someone thinking about it, writing things, some back and forth. while on the other hand, CI is an automated process, and machines do all the thinking for you. Another thing we'll talk about a lot here is contribution speed. So how long does it take for proposed changes to get from the analyst to main? So an analyst comes with some code, says, I want this in main. How long does it take for the changes to get there? So we have the Wild West picture. I'm reusing content flagrantly, sorry about that. But in the legacy world, there were no code checks, no surprise. We had lookers validate content, which is a great feature, but only goes so far. And shout out to Spectacles there, trying to add on to that and improve that. And models and dashboards were often broken. And yeah, we could talk a lot about what broken means. What I mean here is basically something's broken, what you expect to be there isn't. So if it's a data model or a dashboard, the new stuff wouldn't be there, or maybe the old stuff would be gone, there'd be nothing there at all, so kind of broken, in quotes. So on the legacy stack, the kind of biggest fire that was burning was that changes were unreliable. So you make changes, you push them to the main, you wait to see if they work. Maybe they do, maybe they don't. If they don't, start over, go through that process again and again. There was nothing in place to help contributors understand kind of the impact that their changes were making. And I mean, the worst case scenario is you break other people's stuff, which is super hard to check. You go look at all the dashboards you might have touched or all the data models you might have touched, and who knows, maybe they're broken too, kind of hard to check. So yeah, in this era, analysts had to get really good at apologizing to one another. I'm really sorry I broke your stuff. So it was pretty tough. But there was actually a significant advantage to this legacy era, which was the contribution speed was super high, right? You could just merge to main, didn't have to talk to anybody, nothing had to be checked. It was really easy. So yeah, the little horse from the legacy era is kind of in the low reliability, high speed part of this quadrant. In the early modern era, the main focus was on the biggest burning fire, which was that these changes weren't reliable. Things could break all the time. So we introduced CI, and what we had at first was we'd run the proposed changes on live data. And then we also introduced a code review process, and this included standards. We had a standard stock, we onboarded people to it, it developed over time. And in this era, the changes were super reliable. If it ran in CI, it was definitely going to run in main because the run was the same. We ran on live data in CI. So it was super duper reliable. So is this cause for celebration? We thought so. Yes, the biggest burning fire, not there anymore, hooray. But we were actually wrong about that. And there were two big issues with this kind of early modern approach. I guess this is the second issue. All right, maybe some stuff got moved around. But yeah, so the second issue is that the code review became a big burden, because as you can imagine, time goes on, the standard stock grows, contributors need to memorize it and kind of manually think about it and put it in their contributions, and that's a big burden for contributors. For reviewers, it's also kind of boring and slow to review. You have to manually look at the same stuff over and over and over again. It gets to be quite a burden. So an example is we wanted to get rid of kind of corny ref, not using the dbt ref function when you should. So the good case is you use this ref function. The bad one is you have a raw reference to the relation, database.schema.relation. So we had at the beginning of the early modern era 30 analysts. They're making contributions all the time. Each contribution modifies a couple of models. Each model has maybe a couple of from statements, a couple of joins, and each one we have to go through and make sure there's no ref. It was really not fun for us. Yeah, let's see. Another thing, I think the first one's gone. Let me see if I can remember what the first one was. So the standards matured, and also the CI build times increased. That's something that really should be emphasized. So when you run proposed changes on live data, as your data grows, CI is going to take forever. It's going to be super duper slow, not to mention expensive, cost a lot of credits. Each time someone proposes a change, have to run that on live data. So at the beginning of the early modern era, it took a couple of minutes to run the changes on live data. But as things took off, it would take over half an hour. So that was a really big burden for people. And in this early modern era, the contribution speed was super high because it was limited by the amount of time it took for CI to run on live data and the whole code review discussion, the back and forth and changes, stuff like that. Contrast this with the legacy era, where you were limited only by how fast you could type. Like, you type faster, press merge, it's there. So the change reliability, super high. Contribution speed is low. This is something I guess I've already said. But the thing I really want to emphasize is how bad low contribution speed is. So, you have an analyst, they have some code, it has some problems. Do you really want to say, dear analyst, please spend at least another 30 minutes making these changes and hoping that it works, because if it doesn't, it's going to be another 30 minutes to try to fix those new errors. Reviewers don't want to put poor analysts through that. So reviewers get discouraged because at that point, what value are reviewers really adding? Modelers get discouraged because often the stuff they push isn't of that high quality, and also CI takes so long, it can be just a stressful process for them. And overall, the code quality was lower. People were focusing on passing CI. They weren't focusing on writing good code. So yeah, it was bad. Great. So in the present era, we had the goal of increasing contribution speed. That was a big deal for us. And the kind of two prongs of this were decreasing review time and decreasing CI build time naturally. And all the while, we wanted to maintain as much reliability as we had gained in the early modern era, because that was a big win for us. So reduce review time. The general idea here is that we wanted to make as many of these manual review processes automatic as possible. So we did this with PyTest. We'll give some examples later on. But pre-commit DBT is something we want to give a shout out to. It's a great way to get started with this as well. A great package. So no refraf, as it turns out, can be checked automatically. And shout out to Courtney Wright, the great analytics engineer on our team, for writing this test. So you can run a test to say, is there a raw reference to a relation name or not? And if so, you get the feedback immediately. You know where it is, you know what the problem is, and how to fix it. A really quick, nice process. And reviewers don't need to be involved, which is pretty cool. So other examples of things that we have moved from manual checks to automatic checks, enforcing project structure. So for us, we don't want the centralized models to reference marts, so that's something we can check for. We also don't want marts to reference one another. That's something we can check for. We also want models, as much as makes sense, to have descriptions. We can lint for this. And also we can say, okay, if the models are in this folder, they should have that materialization, which is also super useful for us. So in summary, standards in CI, great thing. Easier to review, easier to be reviewed, and much faster overall. So the kind of second prong here is reduce model build time. And the first thing to say is Slim CI, it's a great feature. It allows you to only run the models that have been changed and things downstream from them. Really sped things up a lot. So yeah, that's great. Another thing we did, and this is a bit more controversial, we'll spend a couple slides on this, is we ran the models in CI on empty data. So we didn't have live data anymore. We had absolutely no data whatsoever. So in DBT ease, the way we did this is we made a CI target, and we customized materializations and also seeds so that when you built against that target, there was a limit 0. Well, in the models and the seeds, there was something similar to that. So CI runs were over 6 times faster, went from at least 30 minutes to around 5. So that made things a lot better. And yeah, we also have some ongoing improvements to speed this up a bit more as well that we're excited about. So I think the big question is, all right, you're not running on live data anymore. What about this reliability you've gained? And yeah, so the short answer is reliability is still much higher than it was than when we didn't run any checks whatsoever, but there was a small cost to reliability. And it should be emphasized that when you run models on empty data, you still catch quite a lot, right? You catch issues with refs, invalid SQL, and column names, and a lot of other kinds of things. But what don't you catch? So live data catches things where the models have certain expectations of the data. So a good example of this is like tests, right? Unique and not null tests. So those expect that there are data there, and you can say, oh, it's unique or it's not null. And it's hard to do that when you don't have any data in place. The thing I want to emphasize is, as data modelers, these errors are actually quite common, right? When you build data models on top of changing data, the data often changes to break the expectations your models or your tests make of it. So these errors are, not fun to resolve, but they are routine to resolve. They're something that we're used to working on. So the last point I want to make here is, depending on your definition of quality of code, which is another interesting discussion to have, CI on empty data dramatically improve data quality. So when errors appear, it's super fast to fix them. It's really straightforward. And modelers don't just focus on getting models to pass CI anymore. They also can focus on writing good code, because this iteration speed makes it a lot easier to make those changes. So wrapping up, it's important to think about the analyst experience of CI. What is it like for them? OK, so things break all the time, but what about the fact that it's really fast? I mean, the contribution speed's super high. That's something that they really rely on and enjoy. So while CI can do a lot for reliability, contribution speed should be a factor that we take into account as well in the analyst experience of CI. It's a healthier code base, happier modelers and reviewers. And here, I think this might be a little pompous. I don't think everything's perfect. We definitely still have some ways to go in terms of improving reliability and improving speed. But I definitely think we're out of these low speed and low reliability quadrants, which is something we're super happy about. Awesome. So last little story here is about large-scale data modeling. So this takes us through a specific case of data modeling and some interesting issues we ran into. So you know a lot about what we went through at Miro on the analytics engineering team. And I think there's a good question. What's it like to actually build data models? So in the legacy era, we had a setup that looks kind of like this. So on the one side, there were the raw data sources, and on the other side, there was your MART. So every analyst for themselves, they kind of started from scratch every single time, going back to the raw data. And nothing was ever meant to be reused. What we saw often was analysts wouldn't even reuse their own work. They'd rather copy and paste into something totally different, even if it was exactly the same. So analysts got caught in duplication hell. If everything's duplicated, which one do you rely on? It was really quite a frustrating experience to do modeling. So in the early modern era, we introduced shared models, resembled the domain models discussed earlier. And the idea of the shared models is to take these most commonly asked questions about these common business objects and answer them all in one place. So it's a product that we maintain centrally, we are kind of the maintainers of these models, and we work super closely with analysts to make sure that they're useful, and also analysts have all this domain expertise that we can bring into the shared models and take advantage of. So the structure is more or less, we start with sources all the way on the left, and then we have some standardization we'll kind of ignore for now, but in DBT parlance it'd be staging models, of course, things like that. And then these get combined together into shared models. And the hope is that these shared models get used all across the MARTs. We want people to really rely on these, to take advantage of these. We really hope that it makes their life a lot easier. So modelers start from scratch. There's a problem in the legacy era. Here, they hopefully start with a leg up. And duplication hell. So these shared models should be home to these important business definitions and help reduce that duplication. So here's an example. This is a screenshot from our DBT doc site. We have this user model, and it's our user shared model. So nobody has to go figure out what a user is ever again. They can start from this model. It draws, you can kind of see the lines. It draws from a lot of different data sources to have some columns of general interest, and then also it's used throughout the MARTs pretty consistently. You can see kind of big fan out. So we reached a straining point here, and I'll call this the bow tie problem. So the things upstream increased as adoption grew, and there's more useful columns, more diverse data sources to aggregate in these shared models. The things downstream also grew because it's getting reused more and more. It's a kind of success, mark of success for us. So there is actually something bad about having more things upstream, which is that your models become fragile. So if anything upstream of user breaks, then user breaks. And if you have tons of things upstream from user, well, there's a better chance that it's going to break. So break here, I don't mean to get too in the weeds, but it could be like an error or a skip, but basically user doesn't run. Also, as things downstream increase, things get more dangerous, right? Because if user breaks, then everything downstream from user does as well. So the blast radius of errors to user increases dramatically with adoption in the marts. So as you can imagine, fragile plus dangerous is really bad, because it means one little thing upstream from user means tons of things downstream from user break. So yeah, that's what we actually ran into as our straining point, is these shared models were breaking, and they were breaking things in marts, and yeah, it was not a good experience for the analysts. We want the analysts to be able to rely on these models, and they were having a hard time doing so. So in the present era, what did we do? Well, what we didn't do was try to reduce the blast radius. We wanted to keep users, we wanted to keep analysts using the user model as much as possible. The point of these models is that they be reused. But what we did do was we tried to make them break less often, and when they do break, we tried to make them easier to repair. So the approach we took is, I've just called reinforced bow tie, not a great name, but we'd love to hear your feedback on what you would do in this situation as well, what you have done. Great. So it's kind of 3 steps in the reinforced bow tie. The first step is to move business logic to intermediate models upstream of shared, and to have those shared models, like user, join these intermediate models together. So it looks more or less like this. So we have the sources, and then the sources are combined into these intermediate models where the business logic lives, and then all of these different items of business logic, these business definitions, are joined together in these shared models. And I'll give an example here of a column is enterprise. So in terms of reliance on raw data, and again, we're kind of hand-waving the standardization of staging models, stuff like that. But it relies both on the raw user data and the raw org data, in the sense that if a user belongs to an org with a certain plan, then it's enterprise, otherwise it's not. So we combine the user and org models into this intermediate model, where we define as enterprise, and then we join that into user. So in the early modern era, we would have had that business logic in user itself, and the change is to move that upstream. So step 2 is to reduce fan out. So the most common error we came across in the shared models that would have these big effects on marts was fan out. So the user ID would fan out, something like that, and it was usually because of some problem in the business logic. So what we do is we take these intermediate models that we join in the shared models and force them to have the right grain as much as we can to avoid this fan out. So we use a group by or window functions in Snowflake that qualify functions that may be the greatest thing man has discovered, so nice. So that's what we do with these intermediate models. Step 3, and this is a really important point for us, is to test and document these intermediate models. So these are great DBT features, really amazing. Test helps us understand what broke in the business logic layer in these intermediate models. So before all the business logic was in user, we saw that user broke. Sometimes it's not really clear what about user broke. But with the business logic upstream in these intermediate models, it was much easier to isolate what went wrong. The docs also help us figure out how to repair what happened. So earlier I described the definition of is enterprise. That goes in a description of that intermediate model. And then if that intermediate model breaks, we have a good idea of what the model's supposed to do and how we can repair it going forward. And a little bonus here is that the modularity adds some clarity. You have these intermediate models with all the business definitions. It's a bit clearer what's going on, which is quite nice. So wrapping up, shared models make life easy. I have people sharing a pizza to illustrate. And the reinforced bow tie does help mitigate the breakage here. And there is a downside. This isn't a perfect solution. We'd love to hear from you all later on. Updating these shared models is a bit slower. It's a manual check to see where business logic is, at least as far as we can tell. And that does kind of slow down development velocity here. All right, and I'll hand it over to Felipe to talk about key takeaways.
All right, thank you. It's a bit evil to show pizza right before lunch. All right, so key takeaways. So first is that the modern data stack is great. It nets you some really big wins. It really reduces on some problems that you're facing. It is not a panacea, though. So as we grew at scale, we started seeing some points that are still complicated and you need to deal with. One good thing is that a lot of people are adopting this stack and facing similar challenges. So in the community, you're all here, you know about it. You can try to learn from each other and try to progress on these. And going into the 4 stories that we were sharing here. So number 1 is to keep iterating on how you're operating across your data roles. In our case, we have data engineering, analytics engineering, and analytics. And over time, we started to see kind of how can we better work together, what changes we make in processes, ownership, and so on. And we encourage you to do the same, regardless of what kinds of roles you have. Second is if you're being disrupted by data infrastructure, try to avoid that. You should definitely consider migrating to a solution that will allow you to focus on things that are specific to your business and you don't have to handle low-level issues. But if you're not having low-level issues, great. Third is contribution speed are really important and key for a happy environment. And there are a lot of different tricks or things that you can implement that can collaborate this. We had a keynote, I forgot it was Monday or Tuesday, showing how dbt helps push this frontier of having high speed or high reliability and getting this to have kind of a bit more of both. And last part, that shared resources are very valuable. We saw that in the talk earlier as well. And it's important to make sure that they are robust. I think what I was highlighting here is that it's important to get started. They will not start robust. They will not start great. But you can chart this path and kind of keep improving on them. They can become very powerful and a really good tool to avoid kind of reworks and everything. And get people to have this single source of truth. We can chase for that. All right, and then wrapping up, huge thanks to our Miro team, folks that were collaborating on this. Without them, we could not have done this. And so shout out to all our analytics engineering team, folks that could not be present here, Bart, Tom, Nick, Aaron, and all data engineers, all analysts that worked on this. Special shout out to Dylan Baker as well from Spectacles. He worked with us from this transition to legacy early modern. He's now enjoying his honeymoon. And thank you all. Thanks for inviting us here. Thanks for checking out, for whoever's watching online as well. And reach out to us with questions and suggestions. And yeah, thank you very much. Sorry? Yeah, I think we have some time for questions. So if anyone has questions, please, I'd love to hear them.
Yeah.
Sorry, there's one question.
Should I go? Yeah, cool. A lot of your transformations were originally in Looker. What was the process like in terms of what those transformations were valid, what of them had really valuable insights and calculations, and then putting them back into your DBT project and standardizing them? Was that a lot of conversation? Was that a lot of redundancy there in those transformations?
I think there's been a lot of conversation. I'm not sure if I got the question exactly. Is more like how do we approach the modeling part to push for this kind of central, this shared layer and not having duplications? Is that the?
Yeah, a lot of the analysts might have had a lot of value in the Looker transformations there. How did you see what was valid there, what worked, and what has to be brought through into the model?
Oh, okay. So let me see. So the question is, what stayed in Looker versus what went to DBT? Is that?
Pretty much.
All right. Yeah. So basically in Looker, the idea is that we want to have as least kind of a key business logic defined there. I think there's still some parts of it that it makes sense. For example, a couple of things that can happen there are things when people are preparing things specifically for certain dashboards or certain requests from stakeholders where it's about grouping some categories together in a very specific way for whatever reason they have. So it's still good to have this kind of flexibility and not have people like, oh, someone wants to change to group these together with that, and then they need to change everything. It is a bit, you need to watch out for what kind of classifications that, because if that becomes a thing in the business, then it's a good idea to move. So that's what we often talk with people. Like, it's okay if this starts in the Mart, if this starts in Looker. If this becomes something that sticks and people reference this again and again, then it's time to shift this over. Yeah.
Hi, I'm Adam, and great talk. Thank you for sharing. I do have a question about the code review process. You said that your process was improving the quality of the code that was being reviewed, but what do you do about the data quality? What processes do you have in place to ensure that your data isn't changing or that is changing but not in unexpected ways, and to make sure that the numbers are still correct after a PR is merged?
Yeah, excellent question. So I think in terms of DPT features we take advantage of, we use tests, of course, so this is a big thing that we use, and we find the best use of tests is to ensure that the models are doing what we expect them to do. In terms of more systematic data quality, we found with larger data loads, it can be better to have a more systematic framework in place, some solution that's more tailored fit to looking at huge data volumes and assessing whether the quality is met. So yeah, this is something we're actually currently looking into a lot more. We've definitely gotten a lot out of DBT tests, and yeah, we're kind of excited about maybe having a lower overhead on managing, like which things might break. Oh, if I see into the future, what's going to be a quality issue, and having some kind of tooling or framework that takes care of this a bit better.
Yeah, I would add as well that we would love to be able to run the CI with the full data and kind of have the whole audit, but we got to a point that was very just expensive in terms of time and money. So that's what we were trying to test now. So like we were doing, when we are still doing like with empty data on CI, but we're starting to see like, can we get sampling strategies or some, not instead of having limit 0, have limits, I don't know, X amount, and see kind of what is the trade-off there between how much stuff we start catching with this versus how much it costs in terms of time and money again. But yeah, great question. It's definitely open challenge.
Hi. Thank you for the talk. Really interesting. It was a talk about scaling analytics teams, and I noticed that, Felipe, your job title was Data Product Manager. So I was interested in what companies need a data product manager, and what is it that you do?
Great question. So like, as a data product manager in the team, I started off that we didn't have an analytics engineering manager, so it was a bit of working with the team and trying to align with all stakeholders to understand, okay, where are the pain points, where are the critical needs for the business. And right now, for example, we have this peer system where we have analysts are distributed across these domains, and we have needs from each of these domains and these central needs. So my role is really about kind of trying to balance how much can we put into these central initiatives that will give some horizontal benefits across the board, and also try to see like how can we better allocate across domains, which domains because you can have domains that are very loud and like, oh, we need this and that and so on, but they may be a small domain in terms of kind of what it contributes to the business, and you can have domains that are so like critical for the business, but they're not really vocal about whatever they're facing. So trying to surface these and balance these. It is definitely a role that can really depend on like what kind of context, what kind of roles you have in your business, but that's at least kind of how it works for me. Yeah.
Thank you.
Thank you.
Maybe one right here.
Hello. I loved your peer system idea. and you said that one of the advantages was it helped to break down silos between analysts. I'm curious how that is achieved if each analytics engineer is only pairing with a subset of the analyst. Does it not just move the burden of knowledge sharing up the chain?
Yeah, great question. So one thing about analytics engineering at Miro is, the team is centralized. We sync every day and we talk. We have good rituals in place to talk about given tasks. So we actually have a pretty good idea of what we are all working on. This is something I'm sure as the team continues to grow, we'll have to ask more questions about. But for now, actually, I don't feel overconfident saying we have a pretty good grasp on what everybody's working on. But yeah, I think this is a really great question, especially in the context of how embedded should analytics engineers be in certain domains. Maybe it'd be possible, for example, to have a growth analytics engineer who just needs to know about the growth domain and can help cross-pollinate within growth analysts. So yeah, we definitely see this problem coming down the road, and yeah, we're interested in it as well. Yeah. All the way in the back?
Yeah, maybe run around.
Oh, sorry.
If anyone has a mic, you can go.
Hello?
Yeah.
Hi.
Nice.
Yeah, thank you very much for the talk. I was wondering, have you done any sort of overall audit since you implemented the first kind of tests? And if so, were there any new tests that you were like, wow, we weren't catching any of these problems with our initial tests, we need to implement these new ones? Or were there any which were a bit redundant and you changed?
Yeah, I don't think we've had like a full, let's do the full audit, but the process that we have is that whenever something breaks and see like, well, we should have tried to prevent this. So if there wasn't a test in place, we can say, okay, now it's time to put it there. We learned that this can happen. And then we can evaluate out of like what kinds of things are breaking more often. So as Steven was showing, the fan-out was a bit of this, right? So we started seeing kind of these shared models, they would often, something in one source would change unexpectedly, and then boom, like we have duplicate users or something. So then it was like, okay, we should get a test in place. So all intermediate models should have a test for uniqueness. So it's about kind of trying to see kind of what things break and then kind of putting things in place. I had to say, oh yeah, we don't have something to kind of get rid of tests that haven't been failing. So far, the cost of the tests are not that large. There are some tests that can be fairly expensive, but so far we haven't had to deal with this too much. But yeah, nice question. Yeah.
Thank you.
If you have any follow-ups, do you have a?
No, thank you very
All
much.
right, take it.
Okay.
We have time for one more question.
Sorry, I've got a practical question around the hardened bow tie. As you're separating out the business logic into the intermediate models, the downstream still depends upon the output of that, and you might have processes depending upon that. How do you square the circle? Because if it currently fails, everybody knows about it, and if it's decoupled, how does it work basically?
You want to take this one?
I think, let me see if I understand your point is that the blast radius is still pretty large, right? So even if you have the hardened bow tie, if it fails, it will still break a lot of things. Is that it?
Yes. I mean, if you're relying upon that data point, you still have the blast radius. And it might,
Yeah, so that's where I think we put there that like one of the goals there was not that we would reduce the blast radius, as you're saying, like trying to square, like you can do that if that breaks and you have all the things depending on that. Yeah, tough luck, it will break everything. So that's where the focus was trying to make sure that we could reduce the amount of times that it breaks, and whenever it breaks, that it's very easy for us to understand like what exactly happened there. So breaking down into having the intermediate models helped us to see like, instead of having, you have duplicate users and there's so much going on there that you don't know exactly what caused the duplicates, you can have these as separate models with uniqueness tests to see like, okay, so this thing broke here, that was, I don't know, it is enterprise, something went wrong there and we started having a bunch of users. And that will then just stop it will still skip everything downstream, but we know exactly like more finely what broke. All right, thank you everyone, and we can have a joy lunch. You can talk with us later as well. Thank you.